Hello, warriors. This is Miss Lemons, and today we're going to be going through the ions notes. So make sure you have your packet out, a pencil, and at least 3 different colors to write with. Try not to do highlighter. Let's try to do pens or pencils. Okay. Now, before I move on, I want you to know that I'm not going to be walking through the PowerPoint in this video. So you can either watch a separate video of me walking through that PowerPoint, or you can open up the PowerPoint yourself and fill out the notes. But before you do this video, you need to have the notes on the previous page drawn out. Okay? So pause this video, get those notes done, and then we can continue. All right, so here I'm actually going to be starting on the sodium atom, and we're going to be kind of going from there. I realize that the oxygen atom is listed first, but we're going to start sodium atom right now. Now, we were talking about how atoms change if they gain or lose electrons. So we're going to talk about the sodium atom before it does anything. We pluck it fresh off the periodic table. So you can see here, I have an atom of sodium. I haven't drawn in any of the electrons yet, but you can see that my nucleus has 11 protons and 12 neutrons. And before we move those electrons, we are electronically neutral. And that is because we have freshly picked sodium atom from the periodic table, and we know that they are going to be neutral. And what causes them to be neutral is to have the same number of protons as they do electrons. So if we have 11 protons, that means we need to also have 11 electrons. So I'm going to go ahead and add electrons in a red color to represent negative. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Okay, so now I know that this is totally neutral. I've got my 11 protons and I've got my 11 electrons. Now remember, guys, you don't need to know how many electrons go on each ring yet. That's for next unit. Okay, all right, so we're going to go ahead and determine the charge or represent the charge using 2 different methods. We're going to use a charge chart for those of us that are nice visual people, like I was when I was in high school. And then we're also going to show a math equation, just a quick little formula to help us calculate the charge. And we're going to do the same thing over here when we actually change the number of electrons. Okay, so I'm going to fill out this charge chart to show the number of protons that are currently represented and the number of electrons. So you can see here that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 positive charges, and each one of those positive charges has been paired up with a negative charge. So each one of them has been neutralized. So visually we can see that everything's being matched up. This is a neutral atom. Now we can also represent that same visual by using a formula or a calculation. And the formula you're going to use is this up here. So that is protons, number of protons, minus the number of electrons equals the charge. So let's go ahead and create that here. So that's 11 protons minus 11 electrons equals 0. So our charge is 0, aka neutral. Yay. So what is the name of this then? Well, we didn't change anything about it. It's not an isotope, so the name of this is the sodium atom. The symbol is actually going to be pretty much what we've learned in isotopes. So we're going to have our mass number on top, our atomic number on the bottom, followed by the symbol for sodium. Keep in mind that the mass number, that 23 on the top, that is added together by taking the number of protons plus the number of neutrons, we'll just use black, plus the number of neutrons, which in this case is 12 neutrons, which gives us a mass number of 23. Okay, so mass number. And then of course we have our atomic number, or the number of protons on the bottom. Okay, so that's it for our neutral sodium atom. But now let's change it into an ion. We're going to change it into the sodium ion. Okay, so I went ahead and I already filled out the charge chart over here for the protons. Now I'm going to go ahead and add my electrons. Now, you don't need to know why, but this sodium is going to now have 10 electrons. So after we move electrons. So I'm going to go ahead and represent that. So I have 10 electrons here. One of those electrons left. You don't need to know why or how or when. That's going to be next unit. But you do need to know that we lost an electron, and we're going to show how we lost an electron here in our charge chart. So I'm going to add 10 electrons to my charge chart. Now we can see that here we have lost an electron, and so this proton is no longer being neutralized by this electron. So I'm just going to write that. This not neutral anymore. Not neutral. Okay, we can calculate that too by using our little protons minus electrons calculation. As you can see, I've got 11 protons minus 10 electrons gives us a charge of positive 1. Now, that plus is necessary because we're talking about charges. Whenever we say charge, you need to have a symbol in front of that number. It's either positive or it's negative. In this case, it's positive. So make sure you write that positive symbol right next to your charge. Okay, so we get really fancy here. The name of this, if it loses electrons, is just going to be the name of the element and ion. So sodium ion. It's important to know too that when we're talking about cations in this particular case, so this is a cation, we can go ahead and circle that. They have lost electrons, and so we don't really change the name here. We just have the element name with ion. So if you ever hear magnesium ion, think, oh, that must be a cation. If you think calcium ion, oh, that must be a positive cation. Oh, okay. How about the boron ion? Okay, there's all these different ions, and if it ends in the word ion, we know it's positively charged. So I'm going to go ahead and make that a note to myself. If it ends in the word ion, it's positively charged. So I wrote that cations, positive charge, right? Sorry, cations, positive charge, ha ha ha. They don't have a fancy naming convention. We just have the element name plus the word ion. Okay, so the symbol is actually going to be pretty similar to what we saw for the neutral atom, but this time we're adding a charge. So let me start with the base that we had before. So just like we had over here, we have the mass number on top, that's the number of protons plus the number of neutrons, and then we have the atomic number on the bottom, aka the number of protons, right? Nothing has changed, right? We haven't changed the number of neutrons, so the mass is the same. We haven't changed the number of protons, so the atomic number is the same, and so the atom's the same. But this time we've added a charge, and we show the charge over here in the upper right-hand corner of our symbol. So this is a charge atom of +1. We don't really write 1, so I'm just going to put the plus symbol up here. And it's implied that there is a positive 1 charge. If we wanted to represent a positive 2 charge, it would look like this, 2 plus. Positive 3 charge, 3 plus. This isn't that though. It's just a positive 1 charge. And that is our sodium ion. Oh, and one more thing. When we're talking about ions losing or gaining electrons, this usually throws people off as far as which way the charge goes. If we say like the ion loses electrons and it's positive, people are like, wait, we're losing, subtracting, negative. Think about it this way. You're not losing electrons, you're losing negative charge. So if you're losing the negativity, you're slowly becoming positive. So I'm just going to put a little note to myself underneath here that the electrons are also negative. So we're losing negative charges. All right, and it's at this point I feel really happy with the way we've annotated this and gone through. So make sure you pause the video because I'm deleting this and moving on to the oxygen atom. All right, so here we have the oxygen atom. I went ahead and I rewrote that little formula in the upper left-hand corner for me to use down here for our calculations. Now we know that when we pluck an atom of oxygen off the periodic table that it's going to be naturally neutral. We have 8 protons and 8 neutrons, and that means if it's going to be neutral, if we have 8 protons, we also need to have 8 electrons. So I'm going to go ahead and represent that with 8 electrons in my rings, and then I'm also going to represent that here in my charge chart, 8 protons and 8 electrons. Okay, so I went ahead and I've even kind of done it over here too, but we're just focusing on before. We have 8 protons and 8 electrons. That's 2, 4, 6, 8 total electrons that are in that electron cloud. And remember, because we have the same number of protons as we do electrons, that this is going to be neutral. All right, so I've got my 8 protons and 8 electrons. You can see that they're all matching up with each other. Let's go ahead and show that mathematically with our formula. So we have 8 protons minus 8 electrons gives us an overall charge of 0. And just like the sodium atom, because this is plucked freshly off the periodic table, this is going to be called the oxygen atom. Its symbol is going to be an isotopic symbol, isotopic notation symbol. So we know that we're going to have the mass number on the top. And remember, mass number is the number of protons plus the number of neutrons, right? So that's going to go on the top. For this, that's 8 plus 8, so we have 16 on top, followed by the number of protons, aka the atomic number. That would be 8 on the bottom, and then finally our element symbol. Okay, so that's it for our neutral atom of oxygen. But now we're going to go ahead and change that oxygen atom into oxide. Ooh, oxide. Sounds so elusive, so exciting. All right, so what's happening here? Well, we're moving electrons. How are we moving those electrons? Well, it just so happens that oxygen is going to gain electrons. So we're going to go ahead and represent that like this. They came in. So I'm also going to show that on my charge chart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like I've added those 2 electrons. So we're going to write gains 2 electrons. We're going to write it here too. Gain 2 electrons. Great. So now that we've got that set up, we can show this mathematically or even visually. If we gain 2 negative charges, we are becoming more negative, right? We don't have positive charges to neutralize those 2 negative charges out. We can also represent that mathematically. So I will do that now. Getting a little squished here, sorry, but we have 8 protons and minus 10 electrons equals a charge of negative 2. So we got to name this new particle we've created. For anions, negatively charged ions, right? So I'm going to go ahead and circle that. Anions are negatively charged, right? They've gained those electrons. Remember, that's like gaining negative charges. Anions actually do have a special naming convention. You'll keep the root of the name. So for oxygen, it's ox. And then we're going to add this newfangled suffix. It is IDE, oxide. Okay, so whenever we see this ending, this IDE suffix, this is the anion suffix, right? Every single anion is going to end this way. Anion suffix. Don't you forget it. So if I tell you, oh, there's fluoride, well, that IDE tells me that it's a negatively charged atom of fluorine. If I see that nitride, IDE tells me that I have a negatively charged atom of nitrogen. If I have iodide, that IDE ending tells me I have a negatively charged atom of or ion of iodine. If I have bromide, that IDE ending is telling me I have a negatively charged atom of bromine. So that IDE ending, that is your ticket to success. We can tell that it's negatively charged just by looking at the name, okay? Okay, so when we're writing out the symbol, it's actually going to stay much the same. We're going to go ahead and put our mass number on the top, which is protons plus neutrons, our atomic number on the bottom. We're still going to use the same element symbol, but this time, because this is negatively charged with a charge of -2, we're going to represent that by putting our negatively charged portion, our charge, up here in the upper right-hand corner of the symbol. And that is how we look at anions. So make sure you have everything down on this page before I end this video. Again, if you have not watched that PowerPoint or have gone through it yourself and you're feeling a little bit lost or confused, make sure you go back and watch that video or read that PowerPoint. It will probably clarify a few things in this video. Anyway, thank you so much. You guys have a wonderful day. Y'all are rock stars.